So, what exactly are speeds and feeds? Do they even matter? And if so, how much should I really pay attention to them? Well, in today's video, I'm not only going to answer these questions, but I'll also show you 2 practical tests using profile and 3D relief toolpaths. By the end of this video, you'll have all the information you need to decide for yourself. Stick around because I'm about to put my CNC machine to the test, and the results might just surprise you. So what I've done here is I've set up 3 different tool paths for each letter. So we're going to have a 0.5 finish depth, and here's our speeds and feeds that we want to pay attention to right here. So for the T, we're going to have a feed rate of 100, plunge rate 75, spindle speed at 13,000. Test 2, we're going to be ramping up a little bit. We're going to have a feed rate of 300 inches per minute, plunge rate of 200 inches per minute, and a spindle speed of 15,000. Final profile path here, we're going to be testing this at 450 inches per minute, a plunge rate of 300, and a spindle speed of 17,000. So the idea behind this is to, if we can just ramp it up and save time altogether. This is the second set of tests that we'll be running. This is the 3D relief carving toolpath. I have one eagle on the right, one eagle on the left. These are also going to be run at different feeds and speeds. We will not be running a roughing pass on this because I want to see what the 16th inch skinny Jenny will do at various levels. So the first one, we're going to be running a feed rate of 150 inches per minute, plunge rate 100, spindle speed 14,000. While the second eagle will be running a feed rate of 400, plunge rate of 200, and spindle speed 17,000. What I'm looking to see here is how fast can I run this carve on a piece of walnut in the future. Hopefully these tests will help me determine that. I already have everything uploaded on the Onefinity here. So you can see in my toolpath folder, test 1 is going to take us approximately 26 seconds, which is the T. Test 2 will take us 28 seconds. Test 3 will take us 21 seconds. So you can really see the difference in the speeds of these toolpaths. 3D test 1 will take us 9 minutes and 40 seconds. So for the second 3D test, we didn't really see that much of a time difference. Looks like it only took off about 7 seconds. So I'm going to go ahead and up the feed rate to 600, plunge rate to 400, and then my step over, I'm going to increase to 0.025. Okay, so based on those parameters, our 3D test number 2 now has a finish time of 5 minutes and 4 seconds. And really what I want to do, regardless of the settings on Carveco here to produce these toolpaths, what I really need to see is if I can produce these carvings faster than I was before. Make sure that I'm not wasting any time and increase productivity. For test 1, we can see a lot of really fine detail in here. The 16th inch Jenny did a really good job with this. For test 2, we can see that the increase in step over generated additional lines in the relief. So this did not look as good. For these two tests, we can really tell that number one made all the difference here. The quality and the time were definitely necessary to complete a good looking carve here. As you saw during that third test, this machine can really pick up some serious speed. Now, I've broken my fair share of bits pushing the limits, and it begs two important questions. How far can you realistically push a bit before it snaps? And how much quality are you trading off to gain that extra speed? The answer really depends on you, the CNC operator, and the specific goals of your project. Sometimes quality is absolutely critical, while other times you might strategically sacrifice it in certain areas to finish the job quicker. From my experience, feeds and speeds become particularly critical with profile toolpaths. On the other hand, 3D toolpaths consider additional factors like safe Z height, ramping angles, and stepovers. All these settings give you opportunities to boost speed, but at the cost of finer detail. Ultimately, the key to maximizing your CNC's performance lies in understanding your machine, your bits, and your software settings. It's also helpful to know that each manufacturer recommends specific feed and speed settings for various types of wood for their bits. But let's be honest, those numbers usually play it safe. No manufacturer wants you to snapping their bits and blaming them for it. I hope this video was helpful for you. If it was, don't forget to like and subscribe. Leave a comment down below with your thoughts on this topic.